Hi, 7th grade, Mr. Pastel here, and today I want to start by showing you the answers to yesterday's assignment and show you where the tectonic plates actually are and what they're called. So, some of you watched this video before, but it shows the tectonic plates in 3 dimensions, which I think is cool. So, Africa has a tectonic plate. You see there's an Arabian plate in the Middle East. South America has its own plate, which ends on its west coast. To the west of that is the Nazca plate. There's a Caribbean plate between South America and North America. North America has its own plate. Let's just say the Cocos plate is a little plate under Mexico. The Pacific plate is extremely large. Oh, there's a plate around the Philippines. Australia has its own plate. Let's actually go to the 2D map now. Okay, so this is a 2D map of the same thing, showing the plates. So I already went through some of these. Australian plate, Arabian plate, African plate, South American plate. You can see that the plate is not the same size as the land continent that we know. Usually it's a bit bigger. North American plate is very large. Eurasian plate. So Europe and Asia are not two separate plates. They're in one really big plate. Antarctica has its own plate. Antarctica is not actually this big. It's just kind of the map is stretched because you're turning a 3D map into a 3D globe into a 2D map. Nazca plate, Cocos plate. So there's 15 major plates. And here's what I want you to do. So each of those plates is moving. And we have to figure out which direction each one is moving. So how can we do that? We can use our knowledge of convergent, divergent, and transform plates, which should give us an indication of which direction each plate is moving. So let's do some easy ones together. I want you to use red lines for convergent tectonic plate boundaries. So we know that Japan has a lot of volcanic activity. So what I'm going to do is draw a red arrow. Actually, let me just use arrows. Can I change the color of the arrow? I can. So I'm going to do red arrows to indicate convergent boundaries. So the reason I put convergent boundaries there is because we have a lot of volcanoes. We have a chain of volcanoes. So wherever you have a chain of volcanoes, you should add convergent tectonic plate boundaries. Where else were there volcanoes? Let's see. I remember here near California. So red is convergent. So already, if you look at these two arrows, it looks like the North American plate is probably moving maybe west or maybe south. And the Pacific plate is moving north and moving east. Although over here, looks like the Pacific plate is kind of moving the opposite direction. So we got to figure that out. So whenever you see a chain of volcanoes, please have red arrows pointing at each other to indicate a convergent tectonic plate boundary. Let's do divergent. I'm going to do blue. So this is the most obvious divergent tectonic plate boundary. In the middle of the Atlantic Ocean, clearly the plates are moving apart there. So the South American plate is probably moving west, the African plate is probably moving east, and at the boundary, the tectonic plates are moving apart, which is why we saw new seafloor there. The reason I did divergent is because new seafloor is being created there. And it was that way along this almost this entire thing here. I remember there was also new seafloor here. So wherever you see new seafloor, try to do divergent tectonic plates. You're going to have to go back and look at some of your old data. After you do most of the map, so every single boundary should have either convergent, divergent, or transform arrows. So what I want you to do is first look at the volcanoes and fill in as many convergent boundaries as you can. Then move to new seafloor and draw as many divergent arrows as you can. And whenever you have mountains, that will also be convergent. So I can, for India, or basically Mount Everest, I can do a convergent boundary. Okay. And other big mountain ranges, you can do the same thing. Like this was, the Andes are here, the Andes mountain range, so that's probably convergent. So you're going to fill in as much of the map as you can, and then if you can't figure out some tectonic plate boundaries, you're just going to make those transform. Transform means that they're kind of moving side to side if you watch my other video. So let me see. What do I haven't filled in the whole map, so it's kind of hard for me to do side to side. But let's say here, I'm not saying this is true or not, but let's do the color green for transform. That's not bright enough. Actually, let's do, can we see yellow? No. Let's do dark green. So the arrows are going to be going in opposite directions, kind of side to side. I'm not saying this Europe section is the right answer, though. That was just an example. So do your best to add as many red convergent arrows, blue divergent arrows, and green transform arrows, taking a guess at which direction the plates are moving.